Start ArcGIS Pro. Under Create a New Project, click on Blank. Name it BH Water Study and click the Browse button for the location. Save it in the GIS Class Projects folder. Keep the Create a New Folder box for this project checked and click OK. Examine the View Windows ribbon and notice the Catalog pane and the Catalog view side by side. These buttons can reopen either one if it gets closed. In the Catalog pane, switch to the Favorites tab. Right-click the MGIS data folder and choose Add to Project. If it's not in the Favorites tab, choose Insert, Project, Add Folder. Navigate into the GIS class folder. Select the MGIS data folder and click OK. In the Catalog pane, switch back to the Project tab. Expand the folder's entry to verify that the MGIS data folder is now listed as a data source for the project. Click Insert, Project, New Map to create a new map for this empty project. In Contents, rename the map World. In Contents, right-click the world map icon and choose Properties, or double-click the icon. The action opens the map properties for World. On the left, click on the Coordinate Systems entry and examine the current XY coordinate system in the blue highlighted box. Close the Map Properties window by clicking Cancel. Click the Map, Layer, Add Data button, or use the Catalog pane to add the country dataset from the MGIS Data World folder. In Contents, double-click the World Map icon to open the map properties again. Click the Coordinate Systems entry and examine the map coordinate system again. When the first dataset is added to a map, the map coordinate system defaults to the stored coordinate system of the new data. Examine the lower box labeled XY coordinate systems available. Scroll the box up and down to see the entries. Close the Map Properties window by clicking Cancel. In Contents, right-click the country layer name and choose Properties to open the layer properties, or double-click the layer name. Click the source entry and examine the information on the right. Expand the Extent heading and examine the information. Expand the Spatial Reference heading and examine the coordinate system information. Click Cancel to close the Map Properties window. Move the mouse cursor over the map and watch the coordinate values in the lower bar of the map view update the XY location in degrees. Zoom in to the tip of Florida in the United States. Use the cursor to hover over the southeastern tip of Florida and observe the XY coordinates. Open the World Map Properties and click the General settings. Change the display units to degrees, minutes, seconds, and click OK. Click the Map Navigate Full Extent button to see the whole world again. Open the World Map Properties and click the Coordinate Systems entry. In the folder tree on the right, collapse the Layers folder. Expand the Projected Coordinate System folder and examine its contents. Expand the World folder. Click on the Mercator World projection. In the upper right corner, click the Details link to learn more about this Mercator coordinate system. Examine the parameters. Close the Coordinate System Details window. Click OK to accept Mercator World as the coordinate system for the map. Use the Add Data button or the Catalog pane to add the MGIS Data World Lat-Lon dataset to the map. Open the World Map Properties and examine the general settings. Change the display units to meters and click OK. Use the cursor and the coordinate box to locate the approximate coordinate origin where both x and y equal 0. Look for where the coordinates change from west to east and north to south. Add the States feature class from the MGIS Data USA US Data Geodatabase. Open the World Map Properties again and view the Coordinate Systems settings. Find and expand the Layers folder again. Expand each of the 3 coordinate system entries in the Layers folder. In the Layers folder, click on the North America Equidistant Conic Coordinate System to highlight it. Click the Details link in the upper right corner and examine the map parameters. Notice that this coordinate system has a different underlying GCS, NAD 1983, than the other layers, WGS 1984. Close the Details window and click OK to accept the coordinate system. Zoom in to North America, including Central America. In Contents, select the lat-long layer and open the Feature Layer Labeling ribbon. In the Label class group, set the field to Value. Click the Label button to turn on the labels. Find the central meridian, the standard parallels, and the latitude of origin on the map. Choose Project Options and view the Map and Scene settings. Expand the Spatial Reference heading. Scroll down and check the box Warn if transformation between geographic coordinate system is required to align data sources correctly. Click OK and click the back arrow to return to the project. Open the World Map Properties and view the Coordinate Systems settings. Find and expand the Layers folder. Click the GCS WGS 1984 entry to set the data frame to that CS and click OK. Click the Map Navigate Full Extent button to show the whole world again. In Contents, right-click the lat-long layer and choose Label to turn the labels off. Add the circle shapefile from the MGIS Data World folder. In Contents, drag the circles above the lat-long layer in the Contents window. Open the map properties of the world map and select the coordinate system settings. Type Web Mercator in the search box and click Enter. Expand the projected coordinate system and world folders. Select the WGS 1984 Web Mercator Auxiliary Sphere projection and click OK. Use the map properties and the search box to change the coordinate system of the map to Robinson World. Change the map coordinate system to Sinusoidal World. Change the map coordinate system to Africa Sinusoidal. Zoom in to Africa. Change the map coordinate system to WGS 1984 UTM Zone 35S. This one is more difficult to find. Search for UTM. Then expand the UTM, WGS 1984, and Southern Hemisphere folders to find the right one. Add the UTM Zone 35 feature class from the MGIS Data World folder. Choose the Catalog tab above the map to switch to the Catalog view, a more versatile version of the Catalog pane. In the Catalog view, click the Folders entry. Navigate into the MGIS Data, Black Hills, Downloads folder. Click on the first entry, Bench N27HC. The metadata will appear on the right. Take a few minutes to peruse the metadata for each data set in the folder. Save the project and close the world map. Use Insert Project New Map to open a new map. In Contents, rename the map Study Quads. Click Map, Layer, Add Data. Navigate to the MGIS Data, Black Hills, Downloads folder, and use Shift-click to add all of the feature classes to the map. Click OK in the warning window. Zoom to the extent of the study boundary dataset. Open the map properties for study quads and examine the coordinate system's settings. Find and expand the Layers folder. 7 coordinate systems including 3 different datums, are listed. Click Cancel to close the Map Properties window. In Contents, turn off all layers, except Topographic and Study Boundary. Give Study Boundary layer a hollow symbol with a thick black outline. In Contents, double-click the Study Boundary layer to open the layer properties and click the Source settings. Expand and examine the spatial reference carefully. Close the Layer Properties window. In the Geoprocessing pane, search for Project. Click the Project tool, not the Define Projection tool, to open it. Set the input data set to Study Boundary. Name the output data set Study Boundary. And make sure it is being saved in the Home GIA database BH Water Study. Click the globe icon to choose an output coordinate system. Type UTM in the search box and click Enter. Expand the projected coordinate system, UTM, and NAD 1983 entries. Find NAD 1983 UTM Zone 13N and click to highlight it. Click the tiny star icon next to the name to add this coordinate system to the favorites list to make it easier to find again. Click OK to accept the coordinate system, and double-check that the output coordinate system in the tool reads NAD 1983 UTM Zone 13N. Click Run to execute the tool. In Contents, click the second View icon to open the List by Data Source panel. In Contents, find the Study Boundary layer stored in the Home GIA database. It will be by itself, since it is the first data set we have saved there. Find the original Study Boundary layer saved in the Downloads folder. Hover over the database entry to see its full name and location. In Contents, right-click the Study Boundary layer from the Downloads folder and choose Remove. Leave the Contents pane in this panel, List by Data Source, to help keep track of which datasets come from which folder. Open the Map Properties for the Study Quads map and view the coordinate system settings. Scroll to the top of the list and expand the Favorites folder. Click the NAD 1983 UTM Zone 13N entry to select it and click OK. Turn on the Historic Mines layer. Open the Historic Mines layer properties and examine the spatial reference in the source settings. Close the properties when finished. In the Geoprocessing pane, set or change the input data set to Historic Mines. If the tool was left open, this next step is streamlined. Set or change the output data set to Historic Mines, and make sure it is being saved in the Home GIA database. Tab to accept the entry and get rid of the warning. Set or leave the output coordinate system to NAD 1983 UTM Zone 13N. Click Run. When the tool finishes, remove the original historic mines in the Downloads folder. And keep the new one in the Home Geodatabase. Turn on Mineral Districts. Open its layer properties and examine the spatial reference. Close the layer properties when finished. In the Geoprocessing pane, click the circled back arrow to return to the main Geoprocessing pane. Search for and open the Copy Features tool. Set the input features to Mineral Districts. Also name the output feature class Mineral Districts. Run the tool. Remove the original mineral districts from the map. Save the project before going on. Open the map properties for the Study Quads map and examine the coordinate system settings. Expand the Layers folder to examine the coordinate systems present in the map. Notice that 3 different datums are represented here: NAD 1983, North American 1927, and WGS 1984. Close the map properties. Turn on the faults layer and examine its spatial reference in the layer properties. Open the Project tool in the Geoprocessing pane. Set the input data set to false and save the output as false. Select the output coordinate system, NAD 1983 UTM Zone 13N, as before. Carefully click the drop-down arrow next to the listed transformations and examine the other choices, but do not change it. Run the tool. And remove the original faults layer from the Contents window. Run the Project tool to project the Bench 27HC feature class, including the datum transformation from NAD 1927 to NAD 1983. Name the output Bench HC. Remove the original Bench N27HC feature class from the map. Run the Project tool to project the Bench N27MR feature class, including the datum transformation from NAD 1927 to NAD 1983. Name the output Bench MR. Remove the original Bench N27 MR feature class from the map. Save the project. Turn on the public wells layer and examine its spatial reference. In the geoprocessing pane, clear and reopen the Project tool. Set the input data set to Public Wells and click Tab. A red X appears. This dataset has an unknown coordinate system. Turn off all layers except Public Wells, and Study Boundary. Examine the map. The public wells all appear inside the study area. Open the map properties for study quads and view the coordinate system settings. Change the map coordinate system to WGS 1984 Web Mercator Auxiliary Sphere. It is easier to expand the Layers folder and select it there instead of searching. In Contents, right-click the Public Wells layer and choose Zoom to Layer. Turn on the topographic base map and zoom out until the world location can be identified. In the geoprocessing pane, open the Define Projection tool. Set the input dataset to Public Wells. Set the coordinate system to NAD 1983 UTM Zone 13N. Pick from the Favorites folder and click Run. Zoom to the Public Wells layer again. They are now in the right place. Set the map coordinate system back to NAD 1983 UTM Zone 13N. Use the entry in the Favorites folder. In the geoprocessing pane, open the Copy Features tool and copy Public Wells to the home geodatabase using the same name. Remove the original public wells from the map. Turn on the Hill City 24K layer. It does not appear anywhere on the map. Zoom to the Hill City 24K layer and zoom out, way out, until its world location is apparent. Then zoom back to the Study Boundary layer. Open the layer properties for Hill City 24K and examine the spatial reference. Expand the Extent heading in the layer properties. In the geoprocessing pane, open the Define Projection tool. Set the input dataset to Hill City 24K. Set the output coordinate system to NAD 1983. Search for NAD, then expand Geographic Coordinate System and North America. Select the plane NAD 1983 choice. Click the star to add it to your Favorites folder. Run the tool. Datums typically differ by a few hundred meters or less, so zoom way in to the corner of the study area and confirm that the Hill City 24K edge aligns closely with the study boundary area edge. Zoom back to the study boundary layer. In the Geoprocessing pane, open the Project tool. Project the Hill City 24K feature class to the NAD 1983 UTM Zone 13N coordinate system. Save it in the Home Geodatabase using the same name. Remove the original Hill City 24K feature class. Turn on the Mount Rushmore 24K layer. It does not appear on the map. Check where it plots. And then return to the study area. Open the layer properties for the Mount Rushmore 24K layer and examine the spatial reference and the extent. Use the Define Projection tool. To change the label of Mount Rushmore 24K to the GCS North American 1983 coordinate system. It then appears in the right place. Use the Project tool to project Mount Rushmore 24K to the NAD 1983 UTM Zone 13N coordinate system and save it in the Home Geodatabase with the same name. Remove the original layer from the map. Remove Mount Rushmore structure, Hill City structure, Mount Rushmore geology, and Hill City geology from the map. Make sure that the Contents pane is set to List by Data Source panel. Confirm that all of the layers except the base map are sourced from the GIS class Projects BH Water Study Home Geodatabase. Open the map properties for the Study Quads map and examine the coordinate system settings. Find and expand the layers entry. Confirm that only two coordinate systems are listed, NAD 1983 UTM Zone 13N and WGS 1984 Web Mercator Auxiliary Sphere. The Catalog View tab should still be visible in the display area. If the tab is not there, choose View, Windows, Catalog View. Navigate to the Home Geodatabase in GIS Class, Class Projects, BH Water Study. Click on each of the new projected datasets to examine it. Note that the metadata was copied to the new files. Save the project. Open a new map. And rename it New CS. Open the map properties and view the coordinate system's entry. Find the NAD 1983 UTM Zone 13 and coordinate system. Right-click it and choose Copy and Modify. Rename the coordinate system NAD 1983 Black Hills Transverse Mercator. Change the central meridian from -105 to -103.7 and click Save. Right-click the new coordinate system and choose Save as Projection File. Type NAD 1983 Black Hills Traverse Mercator for the file name. Note the folder it will be saved to, and then click Save. Click OK to accept the new coordinate system for the map. Create a new map. And rename it Turkey. Zoom to Turkey in the map. Find the approximate central longitude and range of latitudes of Turkey using the cursor and reading the values from the Cursor XY display box. Open the Turkey map properties and view the coordinate system settings. Click the Add Coordinate System drop-down and choose New Projected Coordinate System. Enter Turkey-Lambert Conformal Conic WGS 84 as the name. For the projection, choose Lambert Conformal Conic from the drop-down list. Carefully change the central meridian to 35 degrees. Set the standard parallel 1 to 37 degrees. Set standard parallel 2 to 41 degrees. Leave the geographic coordinate system as WGS 1984, a good choice. Click Save. Right-click the new coordinate system and choose Save as Projection File. Retype the name and save it in the Favorites folder. Click OK in the Map Properties and view the map.